Hello, my name is Montana Mendy. I'm a Rails engineer and developer relations manager here at Travis CI. So I guess you could say I'm sort of a jack of all trades here within Travis CI. So first and foremost, I'd like to say thank you for your interest in Travis CI, AWS, and G2. Paul?
Hi everyone, I'm Paul and I'm the product marketing manager here at Travis CI. In a nutshell, I operate between the marketing, product and sales teams to bring new products and features to the community. We're very proud to be working closely with ARM and have seen our own user base grow incredibly over the last year with more and more projects targeting the ARM architecture specifically. We're now really excited to have launched support for the recently announced AWS Graviton2 processor, and we're seeing many of our users taking advantage of the speed and versatility the Graviton2 family of processors offers. Montana, it's over to you.
Thank you, Paul. So I'm just going to go over a couple of things in this slide really quick. We're going to be doing introduction to DevOps concepts, setting up a Travis CI project, the DevOps lifecycle, deploying to AWS Graviton2, and config optimizations and other examples to help you get running. Here's Paul to take you through the basic of DevOps.
So before we jump into the demonstration that Montana's going to do of how to set up a Travis CI project with ARM and Graviton2, I'd just like to take things back a step to give a little context. Appreciate there's going to be a number of you that are well versed in what DevOps and continuous integration is and how that fits into the development world. But for those early on in the journey and for those slightly further on without giving away any of our ages, that may need a bit of a refresher, here goes. Out of the textbook, DevOps is all about reducing the time between making coding changes and the change being made visible in a production environment, all while maintaining a high quality of code. In practice, this usually involves using a platform like Travis CI to take a developer's code, test it, build it, and then when all the lights have been turned green, transfer the package code to a live server. As you can see from the incredibly simplified diagram, thanks to automation, the DevOps process gives a developer almost instant feedback on about how good or not so good their code commit has been, allowing them to take action well before any offending code makes it back to the main code base. Ultimately, at its core, DevOps is all about culture. It promotes collaboration between developers, it improves the processes and efficiencies of development teams within organizations, by giving them the confidence to consistently deliver bulletproof code. So now we've covered that, I'll let Montana take us through the actual demo itself.
Thank you, Paul. So we are going to be setting up a Travis CI project, and I want to show you the base of the YAML file and what each key value does. So I'm going to start a video, and we'll take it from there.
Okay, so let's get to the base YAML file. First, we're going to do operating system. We're going to do Linux. Then, distribution. We're going to do focal faucet. Group, we're going to do edge. Vert, we're going to do LXD. And we'll talk about some of these a bit later on. Arc, ARM 64, Graviton2. And for this example, we're just going to do a compiler, Clang, and of course for the script, we want something super simple. Let's just print out the version, obviously. So let's go by one. For the operating system, as you guessed, this is pick your OS. For distribution, we pick Focal. Now for Arc, this is where we invoke Amazon AWS Graviton2. This will be imperative in all YAML files if you want to use the ARM 64 Graviton2 architecture. Now, vert. There's two items we can use here, LXD or a VM. It's really up to you and what you need. But for this example, we're using LXD.
Okay, so from that video, you get a pretty good base knowledge of the actual core of the YAML file and how to invoke ARM64 Graviton2. Now, let's get a little deeper. Now that you understand the YAML file, let's see what each value does of the YAML file.
I just described each variable that's gone into making this Travis YAML file to be redirected to AWS Graviton. Now, let's focus on a few other things to confirm we are running and using AWS Graviton via ARM64 Graviton2. To clear some things up, the difference between LXD and VM is container use kernel components from the host OS. VMs have their own kernel. The job started on a VM, if you specified virt VM, is just a single VM. Let's jump to Travis.
Finally, now we understand what each value does. Let's bring it all together to perform a build on Travis CI.
Okay, we're in Travis. So let's enter our custom config. So, as we were talking about earlier, let's pick our OS. Let's do Linux. For disk, let's do Focal. For group, let's do Edge. For virt, remember we can do VM or LXD. Right now, I think I'll do LXD. Now, let's invoke Graviton2. And for the example, we're going to do compiler, clang, script, and we'll just make it where it prints the version out. Let's trigger the build. As you can see, the build's successful. And we used ARM64 Graviton2.
Okay, successful build using AWS Graviton2. Now on to the Travis CI DevOps lifecycle. There's 4 of them. There's phase, job, stage, and build. And some problems that you might be facing specifically in a YAML file when you invoke a build is overcaching, misusing Travis branch. So that is, of course, if you're using a bash script, you may misuse that and that will cause the build to fail. And of course, the classic having 2 builds per PR, which is a very common mistake. So be careful of that. Okay, so up next, I wanted to show you a real life situation, and how you would use AWS Graviton2. So what I have done is I have made an open SSL repo and added G2 in it.
Now that we went over the base YAML file, how to invoke ARM64 Graviton2, some of the basics like virt, LXD, and home, I want to show you how fast in practice ARM64 G2 actually is. And what I've done is I've forked the OpenSSL G2 repo and have added ARM64 G2 architecture in the YAML file. As you can see, things are already starting to build. You'll see here ARM64 Graviton2. This is how you'll know you're using it. One just finished building. Let's go back. as you can see, G2 is already built. Regular ARM64 is still building. This job is also running ARM64 Graviton2. There are many ways you can confirm this, but the easiest way is to look at this. And of course, G2 is still building, the final one. And there you have it. Both ARM64 Graviton2 builds are already done, while the ARM64 build is still building. In my experience, the ARM64 build will go about 14 minutes. Of course, we're not going to sit here for 14 minutes, but that is my experience.
You can imagine it's quite similar in a real-world scenario, if not a mere image of what you just saw. And this is what you would do to invoke Graviton2. As you can see, you can build using the power of ARM and AWS Graviton2. Some other use cases that I've used this in, and you probably will too at some point, and this is to really optimize the build on top of AWS Graviton2. And from my experience, you want to use more bash syntax, give jobs names so you know what they do. So many times I've seen people give jobs names that they have no idea what they do, and it slows the build down by minutes. So they have to go back into the YAML file, flip-flop things, it gets messy. On the flip side of that, try getting rid of some jobs in the build matrix, minimal jobs in the build matrix. And last but not least, take advantage of Travis's caching and build stage features. We talked about over caching earlier, but again, you can still cache and still make a really big impact in build time. Paul?
Thanks for that, Montana. Thanks for going through those examples in detail. I think we can see how, firstly, building projects using a solid foundation in DevOps, and specifically continuous integration and deployment, helps get code from a developer's machine to a production environment as seamlessly as possible. Secondly, understanding how to make changes to a stock configuration and utilizing the combined power of build architectures like ARM and AWS Graviton2 really is a game changer for the development process. There are a huge number of prominent open source projects using the ARM architecture with AWS Graviton2 and Travis CI, such as OpenSSL, Apache HTTPD, Tomcat, syslog-ng, and Ruby, just name a few. And the numbers continue to grow, which is great. We hope to see your projects amongst those in the ranks too in the near future. So without further ado, I'd like to say thank you very much for your time today. Feel free to reach out to either Montana or myself, and please ask us any questions you may have.